Okay, today we are going to try to solve rational equations that are not proportions. So when a rational equation is not expressed as a proportion, you can solve it by multiplying each side of the equation by the least common denominator. Of the rational expressions on each side. We've looked at finding the least common denominator before in previous sections, and so hopefully that won't be an issue for us to find that least common denominator. And again, my suggestion is going to be to show work. It's going to be to write out each term, and then we'll multiply by the LCD over 1, so it's easier to see what cancels, okay? So first let's look at letter A. And in letter A, we have 3 over 2 plus 4 over x minus 1 equals x plus 1 over x minus 1. So first let's find, well, we want to factor our denominators. We notice our denominators are already factored, so we can find the least common denominator. We look for regular numbers, 2. We look for powers of x, there are none, and we look for quantities, x minus 1 to the first power, and that's it. Now notice we're solving equations, and so we want to make sure that our denominator can never be 0. And really, if we look at the least common denominator, that will help us find any domain restrictions. And if we set each piece of this equal to 0, we can see that x equals 1 would give a 0 in the least common denominator, and therefore in the denominator. So that's going to be our domain, is that x cannot be 1. Okay. So now that we have the least common denominator, my suggestion is to rewrite each term. 3 over 2, leave a space. 4 over x minus 1, leave a space. X plus 1 over x minus 1. Okay? Essentially, what we are doing here is we are multiplying each side by 2 times x minus 1. And then we are distributing that to each term. So notice it's like 2 times x minus 1 over 1 that I can distribute to each term. So that means I'm multiplying 3 over 2 by 2 times x minus 1. If you want to write the over 1, that's fine. 4 over x minus 1 times 2 times x minus 1. And x plus 1 over x minus 1 by 2 times x minus 1 over 1. Again, the reason that we're able to multiply by over 1 instead of like creating like a fraction of 1 is because we're keeping it balanced on both sides of the equation. So multiplying on both sides of the equation is why we're allowed to do that. So then we can cancel any denominators and numerators that we have. So notice in this first term, the 2's cancel. In the second term, the x minus 1's cancel. And on the other side, the x minus 1's cancel. And so notice we're just left with 3 times the quantity x minus 1 plus 4 times 2 equals x plus 1 times 2. So I'll write it as 2 times x plus 1. Notice that we have no more fractions. That's the goal. When you multiply by the least common denominator, there should be no more fractions in that step. And then we can just solve this like a normal equation. We'll distribute 3 times x, 3 times negative 1. Here we just had 4 times 2, 2 times x, 2 times 1. Here I'll combine the like terms to make 3x plus 5 equals 2x plus 2. I can subtract 2x, subtract 5, and I get that x equals -3. Notice, -3 will not make the denominator 0. We found that the only restriction was that x couldn't be 1, so my solution must be x equals -3. And that's pretty much the steps, is that we find the least common denominator, we multiply by the least common denominator, we cancel, and then we just continue to solve. Okay? So again, let's try the same steps in letter B. First, let's find the least common denominator. Well, in letter B, in order to do that, we should factor. X minus 3 is factored, but x squared minus 9 can be factored as x plus 3, x minus 3. And then this x plus 3 is factored. So step 1 is to find that least common denominator. There aren't any quote-unquote regular numbers. There aren't any powers of x, but we do have quantities. We have x minus 3 and x plus 3. And that's my least common denominator. Therefore, that means that if we set that equal to 0 for our domain, we know that x cannot be 3 and x cannot be -3. So if we get any of those answers, that's going to be an issue. So our step 2 was to rewrite the problem. So 6 over x minus 3, leave a space, equals 8x squared over x plus 3, x minus 3, leave a space, minus 4x over x plus 3. So again, I just rewrote the problem, but leaving space because I'm multiplying each side by this least common denominator of x minus 3, x plus 3. And again, you multiply by the entire LCD, okay? So multiply by the whole LCD, not what's missing. We want to cancel everything. So we multiply by the entire LCD. So here we'll multiply 6 over x minus 3 by x plus 3x minus 3. Oh, I did it in a different order. It doesn't matter. 8x squared times 8x squared times x plus 3x minus 3. And 4x over x plus 3 times x plus 3x minus 3. And then we can see in step 3, we cancel and write what's left. Well, here, the x minus 3's cancel, and so I just have 6 times x plus 3. Here, x plus 3 cancels, and x minus 3 cancels, so I just have 8x squared. Here, x plus 3 cancels, and I just have negative 4x times x minus 3. Again, in step 3, notice that we have no more fractions. That's the goal when we have the equations, is to multiply by the entire LCD to get rid of the fractions. And so now in step 4, we just solve. So we're going to distribute. I'll get 6x plus 18 equals 8x squared. Negative 4x times x is negative 4x squared. Negative 4x times negative 3 is positive 12x. So I can combine my like terms of x squared here. And I notice that I have a quadratic. When I have a quadratic, I don't isolate x. I want to get one side equal to 0. So I like keeping the quadratic term positive. So I'm going to move these guys over. And so I have 0 equals 4x squared plus 6x minus 18. Okay? So now I want to try to factor the quadratic. And, okay, I noticed that I can take a 2 out. So I have 2 times the quantity 2x squared plus 3x minus 9. And, all right, I'll keep trying to factor this one. This one, I'll have to make a double bubble. So to make 2x squared, I could use 2x and x. To make 9, I could use 9 and 1 or 3 and 3. I'm guessing 3 and 3 would be a better bet. And so I want to make an outer inner of 3x. So 6x and 3x could work if the 6x is positive and the 3x is negative here. So my factors are 2x minus 3 and x plus 3. And then it's factored and I'm able to solve. We set each factor that involves x equal to 0. And so I find that x is 3 over 2 or x is negative 3. And those are my potential solutions. But before I happy cloud, let's go back and think about our domain. Remember, in our denominator, we had x minus 3 and x plus 3. That means 3 and negative 3 would make the denominator 0. And if we obtain these, would be extraneous solutions. Notice that x equals negative 3 was one of the solutions that we got. Therefore, this solution is considered extraneous, and the only valid solution to this equation is that x equals 3 over 2. Okay? That's the gist of it. Because I'm not here, I'm nervous, so I'm going to do these U-tries with you too. So letter A, 7 over x minus 1 minus 5 equals 6 over x squared minus 1. First, I want to factor everything. Remember that this 5 is over 1. And so if I factor this here, x squared minus 1 will be x plus 1, x minus 1. So step 1 is to find my least common denominator. And I have, the only numbers I have are 1 that stands alone, which we don't really need to write because 1's a factor of everything. There are no powers of x. And I have x minus 1 and x plus 1 as part of my LCD. So that's my LCD. Now step 2, I'm going to write each term, because I'm multiplying both sides by the whole LCD, I'm going to write each term times the least common denominator. And I know that that step takes a lot of time and space, and it might seem a little obnoxious, but it's so nice to see exactly what is happening. You're showing me that you're distributing it to every single term, and then you can be certain what is legal for you to cancel out here. Okay? So I have 7 times the quantity x plus 1 that's left here. I have negative 5 times the quantity x plus 1, x minus 1 here. And then I have equals just 6 over here. So then I would distribute 7x plus 7. And then when I get here, we've talked about things like this before. My suggestion is to do this part first. So if you multiplied x plus 1 times x minus 1, you would get x squared minus 1 plus 1, so those cancel. So you get x squared minus 1 equals 6. And think about it, guys. That makes sense. If we have a sum and difference, that's going to give us the difference of squares. Now I would distribute that negative 5. So negative 5x squared plus 5. I could combine... oh, this was a plus 7, my bad. So then I can combine like terms, negative 5x squared plus 7x plus 12 equals 6. Get the quadratic equal to 0, so I'll subtract 6. And gosh, you know me, I do not like that negative leading coefficient. So I'll just factor out a negative. so that my leading coefficient is positive. I like that a little better. So we get, so let's factor this 5x squared minus 7x minus 6. To make 5x squared, my only options are 5x and x. To make 6, I could do 6 and 1. That doesn't seem to work to make negative 7. I could use 3 and 2. It will work here because I have an outer of 10 and inner of 3. So outer of negative 10 and an inner of positive 3 will make negative 7x. So my two potential solutions are x equals negative 3/5 or x equals 2. Now remember, we have to check if it's in the domain, and we forgot to do that, but if we look here, we notice if this is our least common denominator, we know that x couldn't be negative 1 or 1. So notice that we're safe with negative 3/5 and 2. That's my final answer. Okay? Let's try another one with letter B. The nice thing about letter B is that these are already factored. Like, well, they're not factorable. So we can start right away with finding my least common denominator. I have no regular numbers. I do have a power of x. I just have x. And I have a quantity of x plus 2. And so I can take then each term, and because I'm multiplying on both sides, it's legal for me just to multiply by the entire LCD over 1. And again, this step does take time, but it's really nice to see what cancels. And when we start rushing, that's really when I see people make mistakes and under-canceling or over-canceling, etc. And again, each of these things that we're doing, adding and subtracting expressions, complex fractions, solving with the least rational equations that aren't proportions, each of them has a different amount of steps. So please practice these steps. So now in step 2, I have this written out really nicely. I've distributed the least common denominator to each term on both sides of the equation. So now I can cancel my denominators, and let's see what I have left. I have 5 times the quantity x plus 2. I have x plus 1 times x. We usually write it with the monomial x in front. And I also have 2x plus 9 times x, so x times 2x plus 9. Okay? Now, at this point, you guys, this is like a chapter 4 question. So, this is new in chapter 8. Once we get to here, I'll review. So we know that we can distribute. And I'm seeing that I am having a quadratic. So I'll want to get one side equal to 0. Before I do that, though, I like to clean up each side. So I'm going to combine my like terms together. So here I can combine the 5x and x to make 6x. So I end up with x squared plus 6x plus 10 on the left and 2x squared plus 9x on the right. You can move anything. Again, I, if possible, like to keep the quadratic term positive. So I'm going to move all of these pieces over. And you don't have to write this, but for those of you that have trouble with signs, I just want to show you why I'm getting the signs I'm getting. So I'm getting x squared plus 3x minus 10. And that doesn't look too bad to factor. There's not a greatest common factor, but I could write a double bubble. I can use x and x. And factors of 10 that make 3 are pretty obviously going to be 5 and 2, positive 5 and negative 2. And so I have two potential solutions, x equals negative 5 and x equals 2. Let's check to see if any are extraneous. Ooh, I see a 2 up here. But let's look. This is telling us that x can't be 0. if we set x plus 2 equal to 0, that tells us that x can't be negative 2. But both negative 5 and positive 2 are fine. So here, again, is an example of where both solutions end up working. Okay? So those are the steps that you're going to follow for most of the problems today. Next, and finally, on the back, we have an example of a story problem. This says, so far in your tennis match, you've put into play 22 of 44 first serves you have attempted. Find the number of consecutive first serves you need to put into play to raise your first service percentage to 60%. Well, right now, 22 out of 44 is 50%. That means you're going to have to make a lot in a row. That's what this is talking about. You're going to have to make a lot of them in a row in order to increase that 50% to 60%. So how would we do that? Remember that when you find percentage, you're going to put in this case, you'd find the serves that you'd put into play over your total serves. And that's going to give you your service percentage. So your serves in play over your total will give you your percentage. So right now, we have 22 first serves in play. And we took 44 first serves. But now what we're doing is our x value is going to represent basically the next first serves. And again, we want them to be in play. And so what we're going to have to do is that, yes, we've had 22 in play, but now we want all of these other ones to be in play also. So our numerator becomes 22 plus x. But if they're in play, doesn't that mean we took the serves? So that's why we also have to add the x down here too. If they were in play, then of course we had to take them. So we want 22 plus x over 44 plus x to represent our service percentage. And we wanted the service percentage to be 60%. And so there are a couple ways that we could do that. We could write 60 over 100. That would be fun. We'll use decimals. We'll say it equals 0.60, just because I think that's what I did online. And then what we could do is think about cross-multiplying like we did yesterday. Isn't 0.60 really like 0.60 over 1? And then we can just cross-multiply. 22 plus x equals 0.60 times 44 plus x. And then we solve. So my left is fine. If I multiply 0.6 times 44, that gave me 2640. 0.6 times x is 0.60. And then I can start, this is linear, so I want to put all my x's on one side. So I'll subtract 0.60x. Then I can subtract 22. And divide, and I get x equals 11. So I need 11 consecutive first serves in play in order to make my serving percentage 60%. Okay? So that's the gist of this section. So hopefully you will take your time in doing these problems. Don't rush through them. Again, the only new stuff is really, for Chapter 8, is finding the least common denominator and knowing in these type of problems to multiply both sides by the least common denominator, therefore distributing the LCD over 1 to each term, canceling, and then once you get to here, then just check extraneous solution. Other than that, it's just all review. Okay? All right, good luck.